The two most important parts of a coil gun from an electromagnetic perspective are, one, the capacitor and capacitor circuit. What I've got here is a 330 volt 80 microfarad capacitor out of a Kodak FunSaver camera. And secondly is the wire to make the coil itself. And what I've got for the wire is 22 gauge resin coated magnet wire. Works pretty well for making the coil. You can make good, nice, tight turns, and the resin coating prevents any shorting between the wire. So here is the mostly assembled coil gun. This will be the barrel with the coil wrapped around it. There's the two leads that'll go to the capacitor. There's 4 layers at 33 turns per layer. See what kind of range that'll give. This is a switch to enable a charger for the capacitor, and this is the firing switch. Close the contact. And the charger is wired to here on the camera circuit. That'll connect to the battery, which goes right here to the capacitor through a transformer and charges up to 330 volts. This red LED here will light up when the capacitor is charged all the way. And then these two leads will trigger the capacitor. When the camera was together, that triggered the flash through the mechanism of the shutter opening and closing. There's a mechanical switch that closed the contact there. I had to take that off and solder to this piece. The next section will show the coil gun firing. So this is the second iteration of the coil gun. It's extremely similar to the first. The battery still goes into the battery charging circuit here. Still an LED to let you know when the capacitor is roughly full. Same type of charging switch. A little different firing switch here. Take a little higher amperage. But the main difference is in the coil itself. If you'll recall, the first gun had a 1-inch long coil with 33 turns per inch, 4 layers. I upped this one to 8 layers and used a drill to wrap it. Instead of by hand, I was able to increase the wraps to 35 per inch. The reason I did this is the first gun was only able to move a projectile from the back of the pin here to the very tip. It didn't actually fire it very far. So this change, here's the nail I'm using. It's about 1 inch long, and there's a distance of just under 1 inch between the back of the barrel to the very edge of the coil. So it's sticking just into the edge of the coil. So now we'll turn on the multimeter. Turn on the charge switch for the battery. You can watch it charges pretty quickly with the one capacitor in the circuit. Over 300 volts is usually fine. I just hit the firing switch. And the projectile landed right here, so we got just over 5 feet. So that's a pretty big improvement. Now here's 2 other projectiles, same material. It's just a iron core finishing nail. And the reason I want to use these 2 is to show the properties that the effect that the projectile has. This projectile is much smaller. It doesn't actually extend into the coil. So we'll charge it up. we fire. And you can see it only got pulled part way into the coil. It's too small. It was too far away. Now this one is very long. It actually extends almost halfway into the coil, almost to the center. So as we charge up again, fire. You can see that this didn't go very far. It only went 4 feet. And the reason for that is since the nail went partway into the coil, as it got pulled through, part of the nail actually went past the middle of the magnetic field, and the force created by the field was pushing it in the opposite direction, so it acted like a braking force on the nail.